Well, I'm Jason Arndt again. I want to talk about just a kind of a quick overview of Delaware's bridge program. I'm going to talk a little bit about everything. First slide here, we're required to throw this in all of our presentations. It's just our Department of Transportation model, every trip, every mode, every dollar, every one. So I'm going to talk about a little bit about our bridge inventory, and then talk about our current and past bridge conditions, a little bit about our performance measures, a quick slide or two on our bridge budget, talk about our bridge preservation studies, or strategies that we've been incorporated over the past 12 to 15 years, and then some current bridge issues that we're having. So that's not a typo. We only have 1,782 bridges. About 45% of those are MBI length. The remainder are what we call state bridges or non-MBI length. You see the deck areas there, 8.4 million square feet for MBI bridges and just barely 500,000 square feet for our non-MBI bridges. We have 24, I'm going to say fracture critical because it's easier to say, bridges. We have 8 movable bridges, 1 cable stayed bridge down at our Indian River Inlet, the beach area. If anybody that can be here around the weekend, if you get a chance to get down there and see it, it's a real neat bridge. There's a nice restaurant there. The beach itself is nice. We have 38 load posted bridges, and then our average bridge age is 46 years. And just kind of a quick snapshot, you can see we have a lot of culverts. More than half of our inventory is culverts. Of course, a lot of that's our non-MBI bridges. We have almost 600 beam bridges, a little over 100 or so slab bridges, and then miscellaneous other bridges. So this is from our 22 finalized data that we submitted to the feds. We currently just about 85% good for our bridges, and then just about 1.5% in poor condition. And kind of give the breakdown MBI versus state bridges. So historically, for the past 12 years, as Jason mentioned, 2011 we were at almost 73% good, and now we're at 85% good. You can see the trend up. And then likewise down at the bottom, the poor condition bridges, we were almost at 7.5% back in 2011, and we were now down to 1.5%. A lot of reasons for this. Started throwing a lot more money at our bridges, a lot more work on the preservation, preventive maintenance side of things, incorporated some different strategies to address our bridge conditions. And as Jason also mentioned, combining bridge management with bridge design and kind of creating a whole separate structures unit really helped out. So performance measures. So Delaware is stubborn. When the feds changed the definition of fair condition back in 2016, I think it was, we still look at fair condition as MBI 5. So when I say good, that means MBI 6 through 9. Poor condition is obviously still the same. Our current performance measures, goals for our bridges, we want to have more than 75% in good condition and then less than 3% in poor condition. So we're in AASHTO BRM state for both our bridge inventory and our deterioration modeling forecasting program. I developed that probably back in 2019 through 2021 with the help of a couple others from our section. This here is a slide from our our meeting from our senior leadership earlier this year, and it's the 10-year forecast for our bridges. You can see, wow, barely see that. About 85% there for 2023, and then it looks like around 87% 10 years out, but we're well above that 75% performance goal that I showed you earlier. And then likewise for our poor condition, by the end of the 10 years, we should be around about 0.5% in poor condition. So we're looking really good. And this just shows shows the forecast with the current budget, and then the same forecast with an additional 10% of budget increase and then a 10% decrease in the budget. The real important line here is the kind of dotted line at the bottom. You can see that that dotted line's heading back down towards that 75% towards the end of the 10 years. And for the poor condition, it's heading up to that 3% at the end of 10 years. So just with that 10% decrease, it really jeopardizes our bridge program over the next 10 years. So we want to, we can't cut funding essentially. So this is our bridge budget. Now this is strictly just bridge work, whether it's replacement, rehabs, preventative maintenance. It doesn't include inspections, doesn't include any kind of other structures. It's essentially on average $73 million per year for the next 10 years that we're planning on. I was during the orientation lunch earlier, I think it was Allison from Massachusetts said with the additional federal money and some state legislature approval money that they got like $3 billion that they're going to be spending in the next few years. So, I could work here for 30 years and we're never even going to spend $3 billion. So it shows you how small our program is. So some preservation strategies. A lot of these are no different than what your state does. We have a concrete deck sealing program. We use penetrating sealers such as silane, but we'll also use methacrylate for actual hand sealing cracks in the deck. If there's a lot of cracks, we might flood seal the deck. We started this in late 2018. To date, we have done about roughly 170 bridges. We have roughly 520 bridges with concrete decks. And our goal is with this program is that we reseal the deck every 5 years. Then we also have a bridge painting program, painting our steel bridges. While we're out there, we'll also paint concrete rails, concrete substructure units as well. We have 361 bridges that are steel supers. Assuming a 30 to 32 year out of the paint life, that's roughly 10 to 12 bridges per year. We're not really doing that right now. We're probably more in the 7 to 10 range. So, we're going to have to step it up over the next 5 to 10 years. We have our interstate coming due within the next 5 to 10 years. A lot of bridges, a lot of steel beams. So we have 4 maintenance districts in Delaware, and each district has their own district open-end drainage contract. These originally just started out for replacing like crossroad pipes, not really bridges. But about 2 years ago, we started using those to try to help replace some of our corrugated metal pipe bridges that we have. And then also our North District, or is it our Canal District, sorry, they're actually going to be using that open-end contract to either spray line or slip line 9 bridges that we have. So they've been helpful to attack our CMP bridge inventory. Then we also have a pile jacketing program. These are typically used on steel monotube pile bridges that we have. We have very few bridges with H piles. We have 75 bridges that have monotube steel piles. To date, we have addressed or pile jacketed 42 of those bridges. We currently have about 22 bridges in the works or planned for the next 2 to 3 years. So at that point, we'll have about 85% of the bridges pile jacketed, and then the rest will be, we plan to have done within the next 10 years. Typically, it's steel piles. We have done some concrete piles that were showing some significant deterioration. But most of our concrete pile bridges, first of all, they're typically pre-stressed piles, and they're still relatively new. They may only be 30 to 35 years, and they're just not showing the deterioration yet. But it is something that in the future, we might have to start looking at pile jacketing those as well. Then we have I mentioned we had 4 different districts, North, Canal, Central, and South. Each district has their own 3-year open-end, what we call structured maintenance contract. The bridge section actually funds it. We provide the work, the bridges that need work. We provide the technical guidance, but the actual district will oversee the contract. They deal with the contractor, coordinate the construction engineer inspection, and traffic control issues and all that. These contracts, they handle pretty much everything, but their bread and butter is joint replacement, concrete deck repairs, concrete sub repairs, rail repairs, things of that sort. But we have used it for others as well. We address about 14 to 18 bridges per year using those contracts with an average budget of $6 million per year. And that's typically all state funding. We don't use federal funds for those. And then last, in-house district staff. So unlike some of the Northeast states, our in-house capabilities are pretty limited. In our Central and South districts, they do a lot of pipe replacements, replacing deteriorated corrugated metal pipe, typically with HDPE pipe. And then also our districts that respond to emergency events, a joint popping up in the road, or we had a big storm event. And they do some smaller preventative maintenance stuff like cleaning decks, cleaning out catch basins, drainage on decks, sweeping the bridge decks, resealing poor joints like along your wing walls or your back wall, and some other things. But we're fairly limited. For our interstate system, we do have an open-end deck patching contract, and this is strictly just address, basically it's the rideability more so than anything, any joints, deck patching needs, and approach slab issues. We spend about about $800,000 on that a year. We're actually working on, so a lot of those, the 495 and a northern portion of the 95, the joints are coming due. There's a few bridges that need some overlays, and there's quite a bit of deck patching. So we're actually putting a standalone contract to address that separately to use federal funds to address all those at once in 2 different phases. We're going to do 95 north and then 495 next. A lot of bridges from the 60s and 70s era. For our movable bridges, as I mentioned earlier, we have 8 movable bridges. We have 3-year open-end contracts to maintain those, do the cyclical routine maintenance of those bridges, assist with when the bridges malfunction. Unfortunately, that happens from time to time. And then also complete some necessarily mechanical and electrical repairs that are needed for these bridges. And that's roughly a little less than $5 million per year for all 8 bridges. Last, just the bridge design replacement program. Well, I guess it's not just replacements, but this would be any major bridge replacement, any major bridge rehabilitation, reconstruction such as a superstructure replacement, or maybe even a deck replacement. So some current bridge issues that I want to discuss. So what you see here is no different than any other state. Typical deterioration, things we have to do to maintain our inventory. I'm not really going to talk about these. The first one is our corrugated metal pipe inventory. It's something we've been dealing with since probably 2006. We're sort of past the bubble and towards the tail end. But this chart here on the left, it shows the number of our corrugated metal pipe bridges, which is 110, and then all other bridges. So basically, our corrugated metal pipe inventory is 6%, counts for 6% of our total inventory. But if you look at the chart on the right, we have 9 poor condition bridges that are CMP bridges. They account for 33% of our bridge inventory. So those 9 bridges are currently in the works to be replaced. Some of them were priority replaced this year. The rest will be replaced either later this year or first thing next year. But corrugated metal pipes have been a big thorn in our side for the past 15 plus years. Deck cracking. I think this is an issue that a lot of states are seeing that I talk to. And I'm not talking about an existing bridge, I'm talking about a brand new bridge. Both of these bridges, well, the one on the left, we did a deck replacement project 2 years ago. After about a year being serviced, you can see all the cracks that I have marked out in red there. There's probably even more. Those are the only ones I could just see from the picture. We actually took a couple cores, and what you're seeing at the bottom there, I don't know how well you can see it, but we're trying to see if it's just a surface crack, is it just something shrinkage, what's going on? And we found that the crack actually goes through the whole slab. You can see that in the picture there. It goes around the rebar. So that's pretty concerning. On the right is a brand new bridge that just opened up early this year, first thing this year. This picture was actually taken before it was open to traffic. You can see the cracks there. And the reason they're dark is we went ahead and methacrylated them. But I mean, it's a brand new bridge deck, not even open to traffic. Hasn't really seen anything but, some small minimal construction loads going over it. Kevin Linda, who will be presenting next, he's not presenting on this topic, but he's actually kind of the one from our department in charge of sort of heading the research to try to look into this issue more and figure out what's going on. There's a number of factors, as you can imagine, your deck concrete mix, construction practices, everything, temperature. There's a lot that goes in this. So the next issue is fill loss that we get behind a lot of our sheet pile bridges. Doesn't affect the bridge, no jeopardy for the condition or safety of the bridge itself. But a lot of times the steel sheeting either has lifting holes that were never filled, or maybe when they drove the sheet piles, they split at some point. You just get like a little bit of scour, and now it exposes that split. Or if it's timber, the timber rots. But basically, we'll get fill loss from behind that sheet pile, and then the road behind it settles. So the location you see in here, you can see the little sinkhole on the right, and then you can see the cracking in the asphalt there. So I mean, there's basically a void there. The material has washed out. There's a void, and the asphalt starts settling. We probably get maybe 2 of these a year that we find. We actually did a presentation. John Moore from our department, who will be presenting later today on paint, actually did Steve Richter did a presentation when we were in Burlington back in 2019 on this. But we still see it surface, and it's not a bridge issue necessarily in the sense that it's no safety or it's not deterioration of the bridge, but it's something we got to address. Just shows another bridge here. You can see on the left, the 2 photos, those were sinkholes. Unfortunately, I didn't get a picture of the actual sinkhole until they were patched, but the one's right in the middle of the lane there. So you can imagine driving this road at nighttime and you hit a hole. I mean, that's not safe for motorists, especially for a motorcycle. And there was some cracking as well. So when we find this, typically what we do, we'll go ahead and basically drive sheeting behind the existing structure. So in the center picture there, you see the red marking. That's the new sheeting that we drive behind the existing one. And then in the picture on the right, we'll actually put a cap on that concrete cap and then tie it into the backside of the abutment. That way no more fill can be lost. Of course, we're only going to do this if we still have a lot of life left in the bridge. If we find this on a bridge that's really deteriorated or doesn't have that much life left, we might just look to replace it. Typically, this happens along the coast, so it's areas that are kind of the bridges, roads are built on marsh, real fine silt sediment. It doesn't take much of a hole to start losing that material. And then you compound that with like sea level rise, and a lot of these structures are now starting to overtop. You're getting water from both sides, and finally just that silt finds a way out. Bridge strikes. I know every state has them. On the left is a rolling lift bridge down in Milford. So it was December 30th of 2021. A dump truck pulling a trailer with an excavator on it struck the bridge. You can see all the damage it did. It displaced some of the gearing off the track, damaged some of the mechanical components. We closed the bridge to marine traffic. It was still no issue for vehicular traffic. And then we started working on with a consultant to come up with a fix for that and repair it. And then again in December 28 of 2022, it was struck again before we repaired it. It was another excavator, different company though. Did a little bit more damage, not a whole lot more, but definitely on the mechanical side, did a little bit of additional damage. Basically, to fix this, we had to completely take all this down, the structure pieces, the mechanical, electrical equipment, take it down piece by piece, build a temporary platform support up there, and basically had to rebuild everything. Had to get the original mill rights to fabricate some of the different gearing and mechanical components and structural components, and basically rebuild it. It just actually opened up. It was either last Friday or the Friday before. And then on the right is a covered bridge that we have, not too far from here, the northern part of the state, what we call DuPont country. It was a Friday afternoon in July, so 3-4 weeks ago. A truck came through, struck some of the lateral bracing and cross bracing, tore it down. We went out there and inspected it. Fortunately, this particular bridge, there's steel beams that carry the live load traffic. So the timber truss itself doesn't carry live load traffic. It just carries the dead weight of the covered bridge. Our crew went out, they got material. The following Thursday, they made the repairs. And then the next day, it was struck again, which is this other photo. It, it just happens. We see it a lot. Actually, in 2018, it might not be the. So right here in 2018, what we did is, so this member originally went straight across. We had a truck come through here, struck it, and rather than stop, he decided he's going to go all the way through it and took it all down. Every cross bracing, every lateral brace, took it down and then kept going. So when we went to fix it, we actually kind of did this modification here. And actually, instead of just connecting that back, we actually ran a new member on top. So we got about 6 inches additional clearance there. Unfortunately, it's still not enough. It still gets hit. So this is another bridge that we get a lot of bridge. It's actually a CSX railroad bridge. It's not our bridge. The tunnel on the right is ours, the pedestrian tunnel. This is in the city of Newark, near the University of Delaware area. In fact, the apartment building you see there, that's typically college apartments. Probably at least once a month, we would get a call to go look at the bridge because it got hit. A lot of times it's box trucks, U-Haul trailers. Check-in and check-out time during the college year is usually when we would get called. People coming from Pennsylvania or out of state with their U-Haul trucks, taking their kid to college, didn't know that this existed. They don't drive U-Haul trucks for a living, and they end up hitting it. You can see the truck camper there got damaged. This one's the Penske rental truck. What we finally did here, for years we had a signal sensor. So if you're too high or too tall, the lights would light up and alert you. We had all kinds of signage. That didn't do anything. So we came up with what we call this clanker system. These orange balls they're essentially buoys that you would use out in the bay or whatnot. And we took the mast arm type structure and basically hung these off of them. That way the vehicle hits it, they know they hit it, they'll stop. And we installed these, I like to say about 18 months ago. And knock on wood, to date, we have not had anything hit this bridge since those have been up. It's hideous to look at. We're not going to be able to use these by that covered bridge because it's historical. It's an area where people are not going to like this. But they do work. There's a website associated with these where people comment and take pictures, and if you can look it up, it's pretty funny. When we first put these up, as I said, we're right next to the college. Kids were driving up there, they get on top of the vehicle, and then they're swinging off these balls. We thought about what we could do, put some grease on there or something. We ended up not doing anything like that, but one modification that we did make is, so initially it was just a steel chain with the ball on it, and the truck would hit it, and these things would just go everywhere, and then they'd come back down, get all tangled up. Sometimes they wrap around the mast arm. So what we did is, you see the kind of the chain, daisy chain going from one ball to the next. We did that way they kind of act all in unison. And then you can see kind of up in this area, we got PVC pipes, that way they can't flip over. The first probably couple months was pretty much a maintenance headache to go out here and try to untangle these things and get them out. But now it's working pretty smoothly. So this is a solution maybe that if you guys haven't already incorporated for some of your bridges that get hit, something that you could possibly incorporate. And that's all I have. This is our Indian River Inlet Bridge. This is our one cable stay bridge. It's a nice looking bridge. So that's all I have. Any questions?
This Dick Dunn from GPI. When you showed your improvement on your bridges, your condition of your bridges, did you guys get any increase in funding during that time, or was it pretty much the same? Or?
I guess I didn't mention that. Yes, not necessarily specific. Well, yes, we have. Over time, we kept asking more money for our structural maintenance contracts, just because there's a lot of deficient bridges. We need more money to address those. Not that there was necessarily like a push up to like the governor level that, hey, we need to throw a lot more money at our bridges. I think just slowly we started requesting more money, started kind of taking money from our pavement group and stuff, and so that's how we're able to do that. But yeah, we did increase the funding. That helped big time. Anybody else? All right, well, thanks.